So we've talked a bit about Bayesian statistics and traditional statistics, and now I'm going to sort of nail my colours to the mast and actually say, okay, which is it? Which should you be using, to P or not to P? That is the question. So part of the reason for talking about these distinctions, and you might have heard about Bayesian statistics quite a bit, is there's been a lot of talk about a statistical crisis. This has been in the HSI literature, but also in the scientific literature in general. There's, I said, papers about this, people looking at results, trying to replicate scientific results and finding they don't work. A lot of things. Now, first thing I'm saying, most of the problems that are being talked about recently are well-known problems that have been known about for certainly the last 40 years. And have solutions. It's not that they're unknown problems, it's just I think people become more aware of the potential problems. And some of these are things I've talked about. Some of the dangers that I've talked about are things that happen. People do them, they produce results, and if you're not careful one is as a researcher, you might well produce results that are misleading because of some of these problems. Or as a practitioner, you might read some of the literature. Somebody says something like, 12-point font size is good for a mobile device or something like that, and you might think, oh, obviously I've got to do that because it's what it says, and they've got the statistics to back it up, and actually the statistics are flawed in some way. So there are real problems if you're not careful of both creating flawed statistics, but also that the statistics you're trusting are themselves have problems with them. But I said most of these are well-known problems, well-known solutions. But they're coming to the fore, I think, people become more aware of them. That might be that more people are doing statistics without training. So I think at some points in the past, particularly something like medical statistics, you'd never do, a doctor wouldn't do their own statistics. They would always expect a medical statistician. My first job, in fact, was being a sort of doing computational mathematical modelling in an agricultural engineering research station. And myself and a couple of other people were part of a sort of mini stats consultancy within the research station. If anybody had some stats that they were even slightly worried about, they would come and ask, and you'd talk through it with them and use expertise. I think that happens less nowadays for a variety of reasons. The other thing is some of the papers, again, it's not that there isn't a real problem, but some of the papers that report the problem themselves use, shall we say, slightly flawed statistics in order to exaggerate the problem. There's a little bit of snake oil going on here as well as a real problem. So there are, it's not that there aren't issues with traditional statistics, but it's not also that they're new and unknown ones. So how are you going to compare these? So traditional statistics has a whole load of problems about it if you don't use it right, certainly. Tends to be, when it's used properly, tends to be quite conservative, I'd say. If you think about it, most people don't do an experiment of any sort, they don't do a study of any sort, unless they're pretty sure they're going to get something at the end. If you think of your Bayesian stuff, it's a bit like that one where you're 80% sure your system has actually made an improvement. And yet, the 5% significance saying is a 1 in 20 if it's happening by chance if there wasn't anything happening. So you're pretty sure there is something there, and you take it's not that strict 1 in 20, but it is quite strict if you're pretty sure there's a result going to be there. So I'm using a bit of Bayesian reasoning to work out that. So I think it's relatively conservative. And actually I say, if you're seeing something that says 5%, that's really indicative. Mostly people want something a bit heavier. So it's relatively conservative. Bayesian stats, in some ways, most of the problems we've talked about work for Bayesian stats and for traditional stats. You can cherry pick with both. You can do post hoc hypotheses with both. And if you do those in bad ways, you'll get silly results. So you get a lot of the same points. And there's a few extra issues you've got to be careful of. We've talked about some of those, particularly that danger of confirmation bias slipping in. However, and the other thing though is on the whole, needs more expertise. Now, when I say that, that's probably not true in one sense. It's just that more people have done their basic stats courses and stuff in traditional statistics, and therefore perhaps understand and are more likely to understand some of the pitfalls. So if you're doing Bayesian stats, you're less likely to know those general rules of thumb about what you should and shouldn't do, and mistakes can happen more easily. So as I said, I think that's not to say it's bad to do Bayesian stats, but you just need more expertise, or you need some more advice to make sure you use it properly, because if you're not careful, it's quite easy to actually do it wrong, just like actually it's easy to do traditional stats wrong. So on balance, and I learnt my stats as a traditional statistician and thought the Bayesians were weird folk, so I've probably got a lot of bias here. So, but on balance, I'm going to say stick with traditional statistics, but always do those confidence intervals, or whenever it makes sense to. Don't just put that p-value in, because the confidence interval gives a lot of extra information to somebody in terms of how big an effect is, whether, if it's a small effect, how small is it? Is it in a valid range? So it's, so I would suggest for most times stick to that. You're more likely that people will understand what you're talking about because they're used to seeing that sort of statistics. It doesn't mean it's always the right thing to do, but on the whole, you're probably going to be safer doing that. You're probably less likely to make a huge gaffe that way. However, there's a series of times when Bayesian statistics are not just a good alternative, but are actually the best alternative. They're in some sense the only and sensible thing to do. So for instance, if you know the prior, if you have some really solid knowledge about the prior likelihood of certain things being true, then not using that is silly. So actually, where you have a solid prior, then using Bayesian stats is absolutely the right approach to use. If you're using the stats for decision making where you've got known costs at the end, if you make different kinds of, so for instance, if you're administering a drug, and if you don't administer it, then the person's going to die with a certain likelihood. If you do administer it, then it may or may not have positive effects with different likelihood. You're starting to have costs and benefits you can weigh up. If you're doing that cost-benefit weigh up, often Bayesian stats are great, because what they do is they give you a probability, and then you can multiply the probability by the costs and do your cost-benefit weightings, with the assumption you know enough about the prior for that to be a meaningful thing. So that's good. Another one is, and we saw this with the website example, internal algorithms. Using Bayes for those makes a lot of sense, and there's lots of different techniques that people use that do that. So sort of internally things, you might well use a lot of, not so much Bayesian statistics, but Bayesian techniques. So typically what happens is there's a series of circumstances where I think Bayes is the only sensible thing to do. In the others, I would probably recommend you stick with traditional statistics, but mostly because they're familiar. It's not that they're the only and right thing to do. And somebody who's expert at using Bayesian stats for doing the same kind of thing would probably do at least as good a job. I'm trying to be fair here. You can see that, can't you? Even though I'm pushing in some directions. Crucially, though, for both, whatever techniques you're using, if you're using Bayesian statistics, if you're using traditional statistics, if you're quoting p-values, if you're doing confidence intervals, do it properly. So mention some of those, the things to look out for, to ensure you don't do these things like the cherry picking, that if you're removing outliers, you do it in sensible ways. Understand what you're doing, and I've hopefully the videos in this series make it easier to have that understanding, and try and know what it means, the output you're producing. So when you produce a number at the end, when you say I've done that and it's p less than 1%, when you say you've done that and you've done a Bayesian stats and you say my odds ratio is X, make sure you really understand what you're telling people. And when you read other people's work, of course, that's equally true. I mean, as an example of this, although a lot of people doing traditional statistics sort of know that non-significance doesn't mean no effect, they often slip into doing it. I've seen that happen even more when reading other people's results. Because, shall we say, some of the critical facility turns off because it's the published result. So, doesn't matter, there are circumstances when one technique is better than another, but whatever technique you're using, make sure you understand it.